Today we get to focus on multiplying whole numbers and fractions. We're looking at models, but we're also looking at the standard algorithm. Now, it's something that you guys pretty much already know how to do because we've seen some of it in our bell ringers leading up to today. So with whole numbers, we typically have to make it into a fraction by putting what number as the denominator? 1. So that's something that's super important. We're going to talk about that today, but we're also going to show you, or I'm going to show you how to model that as well. Okay, starting out. Let me get my pen selected. It says, when multiplying whole numbers by fractions, always make sure both products are in fraction form. So, if I have 5 times 1/3 or 4 times 1/2, I want to make sure that I change these into fractions. I have a feeling that's supposed to say factors are in fraction form. That's weird. Can we change that? Yes. Okay. I think that was a mistake on this key. I'm going to say factors because that makes more sense. Since I'm looking for the product. Okay, so now I want to change both of these whole numbers into a fraction by putting that whole number over 1. Same thing for the 4. I'm going to put the 4 over 1. That way I have 2 fractions that I'm multiplying together. Now, I'm going to show you the standard algorithm, but we're also going to model it as well. So I'm going to do 3/4 times 5. And my steps over here tell me change both, it says products again, to fractions. So that just means numerator times numerator over denominator times denominator. So I'm going to start by writing my problem. 3/4 times 5 over 1. I got to rewrite it so that it shows that whole number as a fraction. Now I'm going to do 3 times 5, which gives me 15. And then I'm going to do my denominators, 4 times 1, which is 4. Now this is improper, so I need to simplify it. So I'm going to be dividing 15 divided by 4. How many whole times can 4 go into 15? 3, and I would have how much left over? 3/4 left over. So just a reminder, this is what it would look like if I were dividing it out. This becomes my numerator, and then the denominator is still 4. So 3 3/4. Okay. Now what does that look like? Because yes, standard algorithm is easy. But what does it look like? Because this is something that you do have to understand and you have to know it if you see it. So if I am showing 3/4 times 5, I want to show 3/4 5 times. So I'm going to shade 3/4 5 different times. Remember, multiplication is just repeated addition. So I'm just taking that one factor and showing it 5 different times. We're going to count all of the shaded parts. So 3, 6, if I'm counting these, 3, 6, 9, 12. I have 15 shaded parts. So the shaded parts are fourths because each one of these is broken up into fourths. So that means that 4 is my denominator, and I have 15 fourths shaded. I know that seems weird, but it simplifies the same way that we just did it a minute ago. So 3/4 changes to 3 3/4. So if I were to take like one of these, if I were to take one of these shaded pieces and move it over here, that would make that a whole moving one of these to here makes that a whole, moving one of these to here makes that a whole, so that's 3 wholes, and then I have 3/4 left over. Did everybody see that? Do I need to show that again? Okay. I don't know. Yes or no? Show it again? Okay. All right. Here's another one. So we're just going to do this with the standard algorithm. I'm not going to make you model this one. So first thing I got to do is rewrite it so that 4 is written as a fraction. And then I just multiply straight across. 2 times 4 is 8. 3 times 1 is 3. And this will change to 2 2/3. Does that feel okay? Okay. Moving on to the next one. This time I am multiplying whole numbers by fractions. So it's just flip-flopped. Instead of having the fraction first times a whole number, I am doing the whole number times a fraction first. Actually, no, it's the same thing.
It's the same thing, just flipped.
Yeah.
It is the same thing.
Like, doesn't matter.
No, it kind of doesn't. Okay. So we're going to go ahead and do it again. Just extra practice, guys. We're going to get real good. Real good at this. Okay.
Yeah, place our practice place.
It's a little different. Okay. Step 1. Before we get to step 1, actually, right here. Both products need to be in fraction what? Form, correct. Just going to fill that blank in right here with the word form. They need to be in fraction form. Okay. Step 1, change all whole numbers to a fraction. So I'm going to rewrite it as 5/1 times 1/4. Now I'm going to multiply my numerators. So I'm going to do 5 times 1, which equals 5.
Who said 2?
And then I'm going to do, I'm going to wait for all the talking.
9.
1 times 4, which equals
4.
4. Now I've got to fix this because I want to change this improper fraction to a mixed number. So this is going to change to 1 1/4. Now what does this look like as a model? All right, I want to show 5 1/4, repeated addition again. So I'm going to split each one of these into 4 parts. I'm going to shade 1 of each. Repeated addition. So now if I were to take this one little piece and put it here, this one little piece and put it here, and this one little piece and put it here, that's going to make one whole piece. And then I'm going to have another piece left over. So I'm going to zoom this in real quick because I want to show you something. This is kind of what I was talking about before. I'm going to use a different color so you can see. So this is one piece, 2, 3. I had 5 total pieces shaded. So I put those pieces over here, and it all combines to show 5/4, or it's the same as 1 1/4. Okay, this one, first thing I got to do is what?
Convert it.
Change that whole number into a fraction by putting a 1 under it. And then I'm just going to multiply straight across. 3 times 2 is 6. 1 times 5 is 5. And then I change my improper fraction to a mixed number. 5 goes into 6 how many whole times? 1 whole time, and I have 1/5 left over.
340.
All right, last part. If the fraction is less than 1, then the whole number is going to decrease. It decreases. If the fraction is greater than 1, the whole number increases. So what does that mean? If I'm looking at this problem right here, 3 times 2/5, the fraction is less than 1. So this number is actually going to go down. Why? Because a number times 1 remains itself. If I'm multiplying it by 0, it goes all the way down to 0. So if I'm multiplying a whole number by a fraction that's greater than 0 but less than 1, it is making that number smaller. It's going to be less than what it originally was. If the fraction is greater than 1, meaning like a mixed number or an improper fraction, then it will increase because it's more than 1. We know that a number times 1 stays itself. So if it's greater than 1, it's going to go up.
Yeah.
Okay? So we're going to see mixed numbers later this week. All right, that's it for today.